In this video, we're going to look at independent and dependent events. And we're going to look at how we can find the probability of each of these types of events, and also how to compare and tell what's an independent event and what's a dependent event. So let's first look at independent events. This is when two events, such as A and B, are independent if the fact that A occurs does not affect the probability of B occurring. So this is like flipping a coin and landing on heads from two different ones. It's also like if you roll a die and you got a 4 on the first roll, you picked up that die, and then you roll it again and you got a 3 on the second roll. Notice in both of these events, there's two things happening. It's two separate things occurring. Flipping a coin twice, or flipping two different coins, or rolling a die two separate times. This is different than the probability we've been dealing with, where it's only a single event occurring. Let's take a look at how we can find that probability. We do that by multiplying the two individual probabilities that happen, and that gives us the probability of both of them happening one after the other. Let's take a look at the first example here. So we toss a coin and we roll a 6-sided die. We want to find the probability of landing on the head side of the coin and then rolling a 3 on the die. So what we have to do is first find the probability of each of those individual events. So what's the probability of getting a head on flipping a coin? Well, that's 1 out of 2. And then what's the probability of getting a 3 on a 6-sided die? So if you think about it, 6-sided die, that is 6 sides, 1 through 6. How many 3s are there? There's only 1 3. And there are 6 sides that could show up, so 1 out of 6. Now to find the probability of both those events happening one after the other, we take the probability of the heads, which is 1/2, and we multiply it by the probability of a 3, which is 1/6. And then you simplify that, and you get 1/12. And if it wants it as a decimal, that would be approximately 0.083. That's the probability of flipping a coin, getting a heads, and then rolling a die and getting a 3. It's only like 8.3%. It's kind of low. Let's look at the next experiment. Experiment 2. Card is chosen at random from a deck of 52 cards. So this is your standard deck. It is then replaced and a second card is chosen. What is the probability of choosing a jack and an 8? So what we have to do is we have to think about, well, how many jacks are there in a deck of cards? So for every number, there are 4 of those numbers. So that's 4 jacks out of the 52 cards in a deck. Same thing for an 8. There are 4 8s in the deck out of the 52 total cards. And notice it says that when we drew this card, it was replaced and then the second card is chosen. That's important. So since that jack was chosen then replaced, we're still drawing from the whole 52 deck. So to find the probability of drawing a jack, putting it back, and then drawing an 8, all we have to do is multiply those two probabilities. So we do 4 out of 52 times 4 out of 52. And then we multiply that out, and we get 16 over 2,704. Which then simplifies to 1 over 169 if you divide both by 16. And that, as a decimal, is 0.00 approximately 6. It's really 5.9, but I rounded it to that 6 there. Alright, that is insanely low probability. That's like 0.6%. Next problem. Experiment 3. So in this experiment, we're looking at a jar. It contains a bunch of marbles. 3 red, 5 green, 2 blue, 6 yellow. If we add all those up, that's a total of 16 marbles. Okay, a marble is chosen at random from the jar. After replacing it, so we took a marble out, replaced it, a second marble is chosen. What is the probability of choosing a green and then a yellow marble? So we want to figure out the probability of green and yellow. So what we need to do to figure that out is we need to figure out the probability of green and multiply it by the probability of yellow. So let's find this probability. It's probability of a green marble. Well, there are 5 green marbles out of the total of 16. We looked at it, it was green, it was awesome, then we put it back. Then we want to figure out, well, what's the probability of getting a yellow one? Well, there are 6 yellow marbles, and there are a total of 16 still in the jar. So now to get this probability, all we have to do is multiply those things. And we get 30 over 256. And that simplifies to 15 over 128, which is approximately 0.117. And there's our probability of experiment 3. Again, remember, all we're doing is we're looking at the probability of each individual event and multiplying them to get the total probability, or the final probability. Okay, let's look at experiment 4. A school survey found that 9 out of 10 students like pizza. If 3 students are chosen at random with replacement, what is the probability that all 3 students like pizza? So think of the situation. We got 10 kids in a classroom, and we're going in the classroom, and we don't know who likes pizza and who doesn't, and we're just randomly selecting a student. And we're pulling them out and saying, hey, do you like pizza? And they tell us. We put that kid back in the room, and we go back in, and we choose another student. It could be the same student, or it could be a different student. We pull them out, ask them if they like pizza. Put them back in the room. Then we go back in, choose a student again, pull them out, ask them if they like pizza. What's the probability that all 3 of those students would like pizza? To do that, all we have to do is figure out the probability of each of those events and then multiply it. So the probability that the first student liked pizza was 9 out of 10. We went back in the room. We're pretending that we don't remember who we picked the first time. So the second time we go in, we could have chosen 9 out of the 10 students that would like pizza. And then we'd go back in and we would choose another 9 out of 10 students like pizza. Now from here, we would solve this by multiplying the top. 9 times 9 times 9, which is 729. And then 10 times 10 times 10, which is 1,000. From there, that would just simplify to 0.729, which really is approximately 73%. So pretty high odds when you have 9 out of 10 students liking them to have 3 in a row that would like. That is independent events. In the next video, we'll take a look at dependent events.